Hello guys, welcome to my channel. Our video today based on limit function. Now, to solve limit function, for example, you have one to be name x approaching 1, which is x squared plus 3x minus 4 over x squared minus 7x plus 6. Now, we are solving this using a method called L'Hopital rule, which we are going to differentiate different yes, differentiate both numerator and denominator. So that's L'Hopital rule. We have to use differentiation to differentiate both numerator and denominator. So by doing so, it makes our work very easy and fast. So you're going to have the x approaching 1, which is going to be 2x. So if I differentiate this, I will have 2x. If I differentiate this, I will have 3. Then if I differentiate this, that will be 0. So I don't need to write that. If I differentiate this, I will have 2x. If I differentiate this, minus 7x is going to give me 7. Then 6 is a constant, so it's going to be 0. Now the next thing is to insert the x into this. So that will be 2 multiplied by 1 plus 3 over 2 multiplied by 1 minus 7. So which is going to be 5. Then this will be 2 times 1 minus 2 minus 7, that was minus 5. So the final answer is going to be minus 1. So this is our answer using L'Hopital rule. Let's take another example. Now this is the second example. So we are going to differentiate the numerator and denominator. So that we name x approaching 1. So if I differentiate this one, I'm going to have 3x squared minus 2, which will be 0, over, if I differentiate this, that will be 2, that will be 2 times 3. The 3 will come down, so that will be 6x squared plus 3. Now, putting 1 into this, are we going to have 3 1 squared minus 2 over 6 1 squared plus 3. So 3, 1 square is 1. 1 times 3, that's 3 minus 2, so we have 1. 1 square is 1. 1 times 6 plus 3, so we have 9. So this is the answer. So we can see that using L'Hopital rule is very fast and make it our work very easy. This is another example. We have p squared minus 9, 2p squared plus 7p plus 3. Now we are given that the limit of p is approaching minus 3. So what we are going to do is still using the L'Hopital rule by differentiating the upper one to give us 2p. This will be 0, so we don't need to write that. Now differentiating the lower part, so we have 4p plus 7. So this is our differentiation. Now putting minus 3 into 4p, now it will now be 2 multiplied by minus 3 over 4 multiplied by minus 3 plus 7. So this is going to give us minus 6. This, that's minus 12 plus 7. So it's going to have minus 6 over minus 5. Minus comes to minus, so it's going to give us 6 over 5. Let's take one more example. So we have beta square plus 5 beta plus 4 over beta square plus 3 beta minus 4, where b is approaching minus 4. The same way, the same method. So solving this will be 2 beta plus 5 over this is going to be 2 beta plus 3. Now putting beta approaching minus 4 into this, so it's going to give us 2 multiplied by minus 4 plus 5 over 2 multiplied by minus 4 plus 3. 2 multiplied by minus 4, that's minus 8, plus 3 will give us minus, plus 5 will give us minus 3 over 2 multiplied by minus 4, that's minus 8, plus 3, that's minus 5. So minus cancel minus, we have 3 over 5. This is the answer. Now let's pick another. This is example 4. Let's go to another example. Let's pick a question involving lim. Now we have a question here. Lim x approaching 1, and in brackets we have lim x over x squared plus x minus 2. We are still using the same method. Now remember, in differentiation, if you have lim x, it's going to give you 1 over x. If you have lim ax, you're going to have 1 over x also. Now using this, lim x is 1 over x. When you differentiate it, we have 1 over x over, this will be 2x plus 1. Now lim x is approaching 1, so if I putting 1 into this, we're going to have 1 over 1 over 2 multiplied by 1 plus 1. 1 over 1 is same thing as 1. 2 times 1, that's 2, plus 1, that's 3. So this is our answer. Now let's pick another example involving lim. So example 6, we have, let me write it here. Example 6, we're going to have, we have lim x approaching 0, which we have lim 1 plus x over x. This is another question. Now this is our question. Remember, lim 1 over x, lim x is same thing as 1 over x. Now when you have a question like this, lim this what you have in bracket, it will be 1 over what you have in bracket. So it's going to be, if I differentiate lim 1 plus x in brackets, is going to give me 1 over this, and if I differentiate the lower one, is going to give me 1. So which means I have 1 over 1 plus x. Now remember, we have lim x approaching 0, x approaching 0, and if I put 0 into this, I will have 1 over 1 plus 0, which is 1 over 1. So answer is 1. Now we are moving to question involving sine and cos. So we have lim x approaching 0, in brackets we have x squared minus sine 3x all over 3x plus 2x squared using L'Hopital rule. So if I differentiate this, I will have 2x minus, if I differentiate it as 3 cos 3x over, this is going to give me 3 plus 2x. Now I'm putting a 0 into this. So it's going to give us 2 multiplied by 0 minus 3 cos. If I put 0 here, so it will be 0. That's 3 times 0, 0 over 3 plus 2 multiplied by 0. Now note that when you have this will be 0 and cos 1, cos 0 is the same as 1. Cos 0 will give us 1. So here we're going to have 3 multiplied by 1. So we have minus 3 multiplied by 1 over this should be 3 because this will be turned to 0. So 3 cancel 3, so our answer is minus 1. So let's solve another question involving sine and cosine. This is another example. We have lim x approaching 0 x cubed over x minus sine x. If I differentiate this, I will have 3x squared over this should be 0 minus, if I differentiate sine x, I will have cos x. We have cos x. Now, if I put a 0 here, it's going to give me 3 multiplied by 0 over cos 0. So, which means that this is going to give us, everything is going to give us 0. But we can still differentiate it again because we must not get 0. So we can still differentiate this again. So which is going to give us 6x over, now if I differentiate this, that will be sine x, cos x is minus sine x. Minus times minus giving positive. If I put 0 for here, sine 0 equals to 0. So everything here is still going to be 0. Since I can still differentiate again, so it's going to be 6. If I differentiate it again, I will have 6. If I differentiate this, I will have cos x. So now, in this case, I can now put my 0 into this. Now, remember, cos 0 is 1. So we have 6 over 1. So our answer is going to be 6. So these are the questions on cos and cosine. Now, let's go to a question with infinity. Infinity. So, when we have example 1 to be lim infinity approaching x, lim x approaching infinity. So this is going to be 3x squared minus x minus 2 over 5x squared plus 4x plus 1. Now, there is a logic that you can use to solve this. Whenever you have x or your limb is approaching infinity and the power of your x is the same. If you check here, we have x squared here. If you check here, we also have x squared here. So they have the same power. Just pick the coefficients of the first one, which is 3, then the coefficients of the lower one, which is 5. So this is our answer. This is how to solve our coefficient, the limb infinity, when it's having infinity. So you can say that is a very fast step. Let's pick another question. Now, this is another example on infinity. The power are the same. So you have q cube. So just pick the coefficients of the first one, which is 1, the coefficients of the second one, which is 2. So this is the answer. So it's very easy to solve lim with infinity when they have the same power. Let's go to another example. Now, this is another example. Whenever you have a linear limit, this is a linear. What I mean by linear, they are on a straight line. there is different from when you have x over x squared. This is not linear. So this is linear. Whenever you have a question like this that is on a straight line that is not over anything, so what you're going to do is that you don't need to differentiate. You don't need to apply any formula there. Just put the value of whatever you have into this. So if I put the value here, so I have 2 raised power 4 plus 3y, and our y is 2 plus 6. You don't need to differentiate, just insert your value. So 3 raised power 4, this is going to give us 16 plus 6 plus 6. Sorry, this is minus 6, not plus. This is minus 6. So this is going to give us square root of 16 alone, because 6 minus 6 will give us 0, so our answer is 4. So the answer here is going to give us 4. Another example, let's go to example having exponential. Example having exponential. So you have length x approaching 0, the x is approaching 0. Now we have exponential 3x minus exponential minus 5x over x. Now this is going to give us, if I differentiate this, that will be 3 exponential 3x minus, if I differentiate it as minus 5 exponential minus 5x over 1. If you differentiate x, we have 1. Now when you can put 0 into this, you have 3 exponential. 3 times is 0, that's 3 multiplied by 0. Minus times minus gives us plus, so we have 5 exponential minus 5 is power 0. So which is going to be exponential 3 times 0, that's 0, so that will be exponential 0, and exponential 0 is the same thing as 1, so you have 3 times 1 plus 5, the same thing here, minus 5 times 0, that's 0, so we have exponential 0 is 1, so it's going to give us 1. So this is 3 times 1 plus 5 times 1, so we have 8. So this is how to solve question on exponential. Now another example, this one is not on exponential, but there's this question here. We have x plus h minus x squared over h, where h is approaching 0. And in this case, what we're going to do is, now we are differentiating with respect to h, not with respect to x. So we are differentiating with respect to h. Now if I differentiate this, it's going to be 2. This 2 will come down. Then differentiate h, that is inside this bracket. So this is going to be 1, because it's h, so it's going to be 1. Then write this again, x plus h. Then remove 1 from this power, so that will be 1. Minus, this one is not having x, is not having h. Remember, we are differentiating with respect to h. So this one is not having h. So this will be 0 over 1. Now if I put a 0 for h, so I'm going to have 2 times 1 is 2. That will be x plus 0, because everything is power 1 over 1. So you're going to have 2x over 1, which is the same as 2x. So our answer is 2x. Let's take a look at this example. We have lim t approaching 0, so whereby we have 1 over t minus 1 over this over this. Now, the first thing is to rewrite this t approaching 0. Now, find the SCM. So, the SCM is t multiplied by t squared plus t. That's the SCM. Now, t divided by this. So, you're going to have t, like t, we cancel t, so it remains this one. So, you use it to multiply 1. So, you're going to have t squared plus t. T squared plus t in this. So that means t squared plus t, we cancel t squared plus t. So it's going to remain t. So use this t to multiply this. So you're going to have minus t. So from here, you can have t approaching 0. So you're going to have t squared cos t and this will go over t squared plus t. Now we can see that there is something in common. So you have t squared over. Now if I factorize one t out, it will now be t multiplied by t, the one that I factorized out. So there is 2t here. I've taken one out, so it's going to mean 1t. Then plus t here, I've taken it out, so it's going to mean 1. Now t multiplied by t, that's t squared. So this one and this one can cancel at each other. So you're going to have 1 over t plus 1. Then remember, our t is approaching 0. So if I put a 0 here, so you're going to have 1 over 0 plus 1. So our answer is 1. So whenever you have, in any case you have question like this, your answer will always be 1. Remember. Thank you for watching the video. Please subscribe, follow, and share.